Namaste. Welcome to this channel, Dr.ARM's Chemistry. Friends, last time we were discussing the types of ligands, and now we will discuss the next point, naming the ligands. So when we are trying to write the formula of a complex, then we have to follow certain rules. And when we want to name the complex, we have to also follow certain rules, that is set of rules. So first of all, we will see how to name the ligands. First, if we see how to write a formula of a complex, then we should remember that if the complex is containing only one particle which is complex in nature and another particle may be ionic in nature of simple ionic form, we can take the example of, say, Ag NH3 twice plus, here it is, if we neutralize this charge by Cl minus, we get this formula AgNH3 twice Cl. So here the part shown in this square bracket is cationic, and next part which is ionic, anion. So the name of the complex is composed of two segments, that is a cation, and this portion is called anion. And using the two forms attached together, the resulting species is called a neutral species. So the charge on this square bracket means complex ion is neutralized by this ion. So the resulting species is electrically neutral. But it is composed of two parts. One is cation, another is anion. Here the complex may be a cation or anion. If we take another example, you will understand this condition. Say K3 Fe CN6, K3 Fe CN6. Here you will find that this portion is a cation and this portion is anion. Now if we separate, these are 3 plus charges provided by 3K, and this complex possesses 3 minus charges. So this complex ion is anionic, and therefore it is neutralized by a cation. So sometimes both the species of such case can be complex, means cation can be complex, anion may be also complex. So there are variety of such probabilities. Then, so this is about the components of complex, so which we have separated in the form of cations and anions. So while writing the formula, you will find that cation is shown first, followed by the required anion. Similarly here, cation may be a complex or a simple ion. It should be shown first, followed by the required anion. So because of such combination, the resulting species become more stable. Now we will see how to write the names of the ligands. As we have seen earlier, the ligands are monodentate or polydentate, and depending upon this, the naming method is also changed. So first of all, we will see the naming of classical monodentate ligands. So first we will see naming the classical monodentate ligands. So there are several such monodentate ions, and we will see few of the examples of these ions. So first of all, we will show the formula of these monodentate ligands. Then we will show the common name. And then we will show the UPSC name. So if we will write first the formulae of these ligands. So first is say H minus, then we can have F minus, Cl minus, Br minus, I minus. So these are the halides. Now other ions, that is N3 minus. Means nitrogen has 3 negative charges. Then there is another, that is N3 minus. So there are 3 nitrogens having bonded and having 1 negative charge. Then another is O2 minus. Then we can have Cn minus, SCn minus. So these are few examples. We will see more ligands. When we are considering these ligands as anions, then we are normally using the word such as hydrides. These are containing species are hydrides, or they are called hydro. Then the name of this UPSC name of this species is hydrido. Normally it is called fluoro, chloro, bromo, iodo. Now this is called nitrido. Then it is called azido. There are 3 nitrogens, so it is called azido. Then this is called oxo. Common name is oxo. And the another is cyano. This is thiocyano. Now we will see what are the IUPAC names of these species. Now it is called hydro UPSC name hydrido. Then next is fluoro. So these are also called same way. Fluoro, then chloro, bromo, iodo, like this. Then this nitrido is also written as it is nitrido. Then azido is also named as it is azido, which is used as a common name. Then cyano is also remains unchanged. Cyano. Then thiocyanate or thiocyano is becoming oxo. It is oxo, so it becomes oxido. Then cyano remains as it is cyano. Then thiocyanate becomes thiocyanate. So there is change in this way in the names. So these are UPSC names, but you will find that most of the times these tribal names or common names are used while giving the names to the complex, and these names are used mostly in the while showing the scientific names in the research work mostly. So in this way, these are few examples. Similarly, we can have other names such as hydroxo, that is OH minus. So it becomes also same hydroxo. Similarly, we can have other names. We can have other names such as formula, that is H2O. Then we can have carbon, this monoxide, CS, NO plus, then NO2 minus, then ONO minus, CH3 and C, then PR3, then C5H5N, C5H5N. So these are other few examples. So we can show these names. Their names like this. So water is commonly called, while giving tribal name, we call it aqua, not water. We cannot say common name is water, it is called aqua. Means when there is one water molecule as a ligand in the complex, it is called aqua simply. When there are two such names, it is called diaqua. UPSC names is also in the same way, aqua. That is UPSC names. Then another is this carbon monoxide. It is called carbonyl. Here it is also called carbonyl. Then this is called thiocarbonyl. Thiocarbonyl. Here it is also called the same, thiocarbonyl. Similarly, it is called nitrosyl. Here it is also called same nitrosyl. C. This is called nitro group. It is commonly named as nitro. When UPSC name is given, it is called nitrito. And here it is the point of attachment is oxygen. So it is called O. Now here it is N. The point of attachment is here. Here it is oxygen. Then here same nitrito. It is called commonly nitrito. And here it is called nitrito O. Nitrito O. Then this is methyl isocyanate. Methyl isocyanate. Methyl isocyanate. But it becomes here same. Methyl isocyanate. Then this is phosphine. Phosphine. It is called phosphane. Then another is pyridine. This is pyridine. And it is also called the pyridine. So these are symbolically also sometimes represented, but these are larger names. And pyridine is represented as PY, but other names are represented as they are. Means sometimes they are shown as short forms. If we find the other amines, the derivatives of these species, such as say RNH2. So this is primary amine. So for example, methylamine, when it is replaced by CH3, it becomes methylamine. Similarly, we can have the amido group, that is NH2 minus. That is NH2 minus. So here this is NH2 minus. Here it is amido group, methylamide. But this is common name, that is amido group. But IUPAC name is azanido. This NH2 group is called azanido. Then if it is imido group, that is NH2 minus, we commonly say it is imido group. But IUPAC name is azyl diido. This is called azyl diido, that is imido. So this is about the naming of simple monodentate ligands. Now we will see how to name the polydentate ligands. Polydentate ligands. UPSC name. So there are several such names. Example. So here it is polydentate for example, if we consider NH2, CH2, CH2, NH2. It is called, the common name is ethylene. Ethylene diamine. Ethylene diamine. So it is abbreviated as EN. And UPSC name is 1,2 ethane diamine. Ethane diamine. Similarly, we can have another example, that is tridentate ligand, that is diene. We can have the example NH2 CH2 CH2 NH CH2 CH2 NH2. This is triene. It is called diethyl triamine. Diethyl triamine. That is simply known as triene or diene. This is shortly called diene. Diene. The name is, so if we start from this, it is 147, 1, 2, 3, 4, 5, 6, 7. So it gives 147 triazo, heptane, heptane. So we can name in this way. So 147 positions, 147 positions are occupied by this NH or NH2 groups, means nitrogen donor atoms are there. So in this way we can have other such tetradentate ligands. Having, we can continue in this way, and we can have one more NH2 by attaching CH2, CH2, NH2 like this. So we can get tetradentate ligand. Then we can have the hexadentate ligand. We can have this hexadentate ligand, that is ethylene diamine. That is, we can show this. This is the formula of ethylene diamine tetraacetic acid. So it is called shortly EDTA. Common name has EDTA. And its UPSC name is like this: 1,2-diethane, 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 diene, dinitrile, dinitrile tetra acetate. Tetraacetate. So 1 and this 2 gives diethyl. 1 to diethane, dinitrile tetraacetate. So in this way, the another example is also like this. Formula is like this: CH3 C H. It is not CH3 C O CH C O, and here is CH3. So here the structure is like this. So this is additional or pi bonding. So we can have this name as like this: acetyl acetonate, common name acetyl acetonate, and common UPSC name is 2,4-pentane diino. So these are some chelating agents or polydentate ligands which are used to form chelates of different metals. So we can get variety of such chelating agents. There are many other such examples. So we can have such dipyridyl or bipyridyl. The formula is like this: so this is bipyridyl. So normally it is called bipyridyl. 2,2-bipyridyl. Here the name is also same 2,2-bipyridyl, but it is slightly changed to 2,2-bipyridyl, and shortly it is called pyridyl, bipyridyl. So in this way there are several examples, and there is no need to give the name of every ligand here. So we will stop our discussion here and we will see the naming of complexes and what are the rules are available according to the common or travel name system and UPSC nomenclature system. So we'll see these things in the next lecture. So see you next time. Please subscribe to this channel and press the like button and bell icon. So thank you very much. See you next time.